All right, let's get started. Welcome to the session on benefiting from Java 9 improvements. My name is Venkat Subramaniam. I'm going to talk about two main things in this presentation. One, what I would like to call as improvements or changes. These are things you could do before, but you could do a little bit better now that we have a few other interesting things in Java 9 and of course, moving forward into 10 and 11 as well. And I'll talk about a few different additions, things that you couldn't do as much before, but you could do now. And I will pretty much avoid this topic here today, even though it's one of the most important topics. I think this has been talked about enough by a lot of other presentations and other speakers about modules. I won't talk about that much here today. So we'll talk about improvements to begin with. Well, it turns out, I'm going to say Java 9 is probably one of the most important updates to the Java language compared to all the other releases in the past. I used to say that about Java 8, but of course, Java 8 was still an opt-in and opt-out. You could decide as a programmer how much of it you want to really use, but Java 9, of course, is going to make a huge difference for everyone on the Java ecosystem. So I want to talk about Java 9, but it turns out a lot of us talk about modules, and as I started really digging into Java 9, I realized that there are actually a lot of stuff to really get excited about in Java 9, not even considering modules. So that's what I want to really focus on in this presentation. Well, the very first thing is, let's talk about interfaces for just a minute. Well, think about interfaces. Interfaces have been around in Java from day number 1. So I'm going to have an interface called util here for a minute. Let's go ahead and write a little method here. I'm going to say get, let's say, number of processors. And this is going to be returning to us the number of processors. I'm really playing with the compiler at this moment. So I'll simply say OK here for a minute. And you can see that the compiler is really happy with me so far. But of course, if I try to put an implementation into the interface, that's not going to work really in Java because interfaces are not supposed to have implementations. At least that's the way it was in the past. If I try to really compile this code, Java will get really angry at me. It'll ask me, do you know Java? And you can see that it's complaining right there. So you cannot really do that. So it turns out, what was interface? At least the way I see interfaces is, an interface is a spec, it's a contract. An interface says a lot about what it'll do, but it never does anything. Kind of like my boss. That's what interfaces really are. But having said that, though, that changed very quickly in Java 8, of course. In Java 8, you can write what are called default methods. And as a result here, you can put some implementation here for the default methods. And that's perfectly OK. Well, you also know that interfaces can have static methods as well in Java now. And so as a result, for example, I could put this method as a static method. The compiler is quite happy with it. Well, that brings up the question, if interfaces can have default methods and static methods, which are really implementation, would it really make sense to have maybe private methods? Why would we normally create private methods? Well, normally we do that because we want to take methods that are being duplicated, code that's being duplicated, and roll them into these called helper methods, and that would really be nice to have helper methods. Well, it turns out Java now gives you the ability to do that. So I can say private int, let's say get count, for example, right here, and I can write that as a private method, and as a result, you can see the compiler is quite happy with it. Similarly, I could write a private static method as well, which is a get count 2, and the compiler is happy with that too. And within the static method, I can call the get count over here. And this get count 2, of course, is the method I'm interested in calling. And the compiler is quite happy also with that. And likewise, within the default method, I can call the get count method, which is the private method we wrote. And as a result, that's working fine as well. You cannot put private default over here. This is not a valid operation. You cannot perform this. The compiler doesn't like you to put a default. But if you really write a default, a private method rather, that can be accessed from within default methods. And that's basically what a private method is. Having said that, I'm still not sure if this is a feature or a flaw. I would say if you open a piece of code and see a lot of private methods and interfaces, the developers are telling you need to find a different place to work. And that's what I would say. It's not a really good idea. So I would use this very sparingly, if you will. So you can have private methods and interfaces. One of the improvements I'm really happy with is in the area of try with resources. Well, before we talk about what that is, let's quickly talk about about a class called resource, if you will. So the class resource contains, let's say, a constructor right here, and the constructor is simply going to output, let's say, created. So I have a little method that's creating a little object. Let's go ahead and say this is going to be an op1, just a method. I don't have much to do in here except that simply to say op1, but I'm going to write a method called finalize over here. And within the finalize method, let's go ahead and say, I want to just print out saying clean up, let's say clean up external resources. So if I have, let's say, a file that's open, or a database connection that's open, or a socket connection that's open to a remote server, whatever that could be, I want to clean up those resources. We normally use finalize for doing it. But unfortunately, though, there is some really significant problems with the case of finalize. And one of them is the finalize is called when the garbage collection kicks in. But remember, garbage collection is about cleaning up main memory, not about external resources. And the virtual machine can decide when to call the garbage collection or not even call it at all. So as a result, these external resources may be kept longer than they need. And so this did not work really well. So in that regard, the finalize method was really not a good idea. But thankfully, they took the bold step now in Java 9. And in Java 9, finalize has been deprecated. I truly think this is the right thing to do. And hopefully that will get removed one day. And can you imagine waking up to the day when there is no finalize method in Java? That will be awesome, isn't it? So that's going to be gotten rid of eventually because that was such a terrible idea. But before we talk about a solution, I want to quickly talk about one other thing that I've learned over time, and I want to call this as a life's lesson. And life's lesson is true for programming as well, and that is in life and programming, and I see this quite often, we seem to solve one set of problems only to create a new set of problems. And this seems to be really true for a lot of things we do. This happens in politics, this happens in programming, this happens just in life. Well, now we said finalize is not a good idea, so we want to solve it, but what are we going to do to replace it? Well, this was done in Java 7 when they introduced the idea of try with resources. So what did they propose back in Java 7? In Java 7, they said, well, you know what, finalize is a bad idea, let's not do that. So we have a new method called the close method, and within the close method, you can say clean up external resources. But how do you make sure that the close method gets called within a constraint? So you can say implements over here, and you can say this is auto-closable, and you can implement this thing called auto-closable. Well, by implementing this thing called auto-closable, what you can then do is, I'm going to just make this a void method for now. So you can see that this is going to be called by using the try with resources. So you can simply put a try block right here, but within the try block, you can call whatever method you want to call. But right here, automatically, the close method gets called, as you can see. So this was introduced in Java 7 as a solution to cleaning up external resources. So if you know you want to get rid of a resource, you can use a try with resource really nicely. So that seemed like a good idea. Why wouldn't I be happy with it? Well, it turns out that if we go a little further with this, let's call a method called use for a minute. And the use method right here simply says, I'm going to do this piece of code. So I just moved it around just a little bit, that's all. But in reality, what I would like to do, though, is I want to be able to take this resource, and one of the constraints in Java 7 was that object that you are placing in the try with resource had to be right there in the place where I've highlighted it. So you could probably call another method that creates the object, which you could call as a factory method, but in general, that's pretty limiting to what we can do. Well, if you look at this code, what comes to your mind? What comes to my mind is the words called tight coupling. I don't want my code to be tightly coupled coupled to the resource object. And what do you normally do to avoid tight coupling? You do dependency injection. So what I would really like to do is I want to bring in the resource from the outside right here, and then as a result, I can simply specify the resource object right in here, and as a result, I don't have to worry about creating that object in this context. Then, of course, I can go back here and say resource and call that. Well, unfortunately, this code will not compile in Java 7. This was not allowed in Java 7. And the reason is in Java 7, this object had to be coming into life or context. At that point, it cannot be defined outside of that particular scope. One of the nice things about this solution was, in the earlier approach, the lifetime of that reference ended when you leave this. But of course, the limitation was you cannot do dependency injection. Oftentimes, I want to use stubs and mocks as well for automated testing purposes, and those things were really not that easy. Well, now you can actually do this. As you can see in here, this is Java 9 and beyond, and I'm using Java 11 right now, but in Java 9, this will work. So you are able to do this where you can inject this object into your scope, and you can use it. Like I said, if you're using Java 7, this code won't compile. Java 9 and later it will. Now, obviously, the question is, what are some of the limitations? The first limitation is that this object is considered to be final or effectively final. The reference is. So as a result, if you said resource equal to resource, you'll get a compilation error, as you can see. It says resource used by try with finalize is required to be final or effectively final, so you're not allowed to modify that reference right outside of the block, which is not a bad idea. I like that approach. However, if you notice over here, even though I'm not modifying it, I do have access to the resource at this point, which means after you have relieved the external resource for the object, you can still go back and talk to the object. And that could potentially be dangerous. You have to be a bit careful and do fairly good testing, because you potentially are talking to I'm using the word loosely here, you're talking to a zombie object whose external resource has been cleaned up, and you got to be a little bit careful about it. So that is something that you need to be very careful to make sure the code doesn't really go haywire when you are trying to talk to it. So certainly some improvements, as you can see, but at the same time, some new problems also to deal with. Well, moving a little forward, one of the things that Java has been thinking about is, what if we were to use some things like, make the code a little bit more expressive? In that regard, there are quite a few things that Java can learn and observe from other languages. And one of those examples is a language like Scala and Kotlin. If you look at the language like Scala, the last time I checked, there were 7 uses of underscore in it. And they are all distinctive use of underscore. The jury is still out. There are only 2 kinds of Scala programmers I've ever seen before: those who love underscore and those who hate underscore. And then it's not still clear whether it's actually a nice thing or not. Well, Kotlin uses underscore as well. So if you're looking at Kotlin, for example, if I have a list, if you will, I'm going to say list of numbers over here, and I'm going to say 1, 2, and 3, I could say list.reduce over here, and I could say, for example, maybe a sum comma element, and I can ask it to perform this operation of a sum and element. So in this case, I can say sum comma element and return maybe sum plus element. Well, this would be just fine in a language like Kotlin to get the result, if you will, and then I want to maybe print out the result when I'm done with it. But one of the things that Kotlin does is it actually looks for potential errors in the code at compile time. And as a result, if I were to ignore the sum, I just don't care for it, and if I simply wanted to return e plus e for whatever reason, you will notice this code is going to give us a warning at code time, because I'm not using the sum. Actually, it should have given us a warning. So it should give us a warning that it's actually not known. One of the ways you can actually fix this problem is by using underscores in a language like this. And so what really is underscore? I've been thinking about it for a while, and I finally figured it out. underscore is the international national symbol for a very important thing we all say every day, a symbol for this wonderful words called I don't care. So that's basically what it really is. So if anytime you want to say that I just don't care about this particular data, you can use an underscore to communicate that. So in other words, Java really wants to use underscore, but the jury is still out where they would use it, when they will use it. The chances are you will start using underscore in pattern matching syntax, and I think that's a really good use of it. But one of the problems is if you want to use underscore, what if there are people who are using underscore already in their programs? That would kind of become a mess, isn't it? So to prevent that in Java 8, underscore as a variable name was treated as a warning in Java 8. Well, starting Java 9, that is considered to be an error. So you're not allowed to use underscore in Java 9. And later, and of course, eventually, who knows, Java 12, 13, 14, 21, whatever that time that introduces underscore is reintroduced, there'll be a day when you can actually use underscore again. But for now, you're not allowed to use underscore. So I'm here in Java 11, and if you try to use this, it says as of release 9, underscore is a keyword and may not be used as an identifier. So if you're using underscore already in your code, chances are you're getting warnings already in Java 8. And of course, if you are not getting those warnings, that's great. But if you're going to start using underscore, that's not a good idea. You don't want to use it. But of course, the question is, what do we do instead of underscore? Well, I would recommend giving a civilized name for it. Whatever that value represents, give a name for it. The other day, I had a programmer who got really excited, and he said, oh, that's OK. I won't use underscore anymore. I'll just use 2 underscores. That's not a good idea. Can you imagine opening a source code and seeing code with different underscore lengths in it? But I do have a suggestion. If you really hate the people you work with, refactor the code. All the tests will still pass, isn't it? With arbitrary number of underscores and then walk away. Just don't tell them I gave you this suggestion. But the point really is that it's not a good idea, so don't use underscore. Well, let's move on a little bit further. I'm really excited about some new features added to the Stream API, and I think these are really welcome additions to the Stream API. So to understand this, let's take a couple of different examples and play with it. Let's say I have these numbers, and I want to say 51, and then 16 and 17, 81, 91, and let's say, yeah, that's good enough. So I got a bunch of values, as you can see, these numbers. But I want to take a minute to understand a few different things that are already in Java 8 and a few deficiencies that are being fixed in Java 9 and later. So let's say that I have a numbers.stream, but I want to call the filter method, and I'm going to say given an element less than 50, and then I'm going to say for each, and I'm going to simply print this out. So output, and we will say println, and we will just print it. Now, when you look at this code, it's printing, as you can see, 11, 12, 13, 14. It did not use 51, but it printed 16 and 17, but not 81 and 91. That's the way filter actually works. But let's understand what filter is actually doing. Filter takes a predicate as a parameter. So you're passing a predicate to filter, and what does a filter do? It is like a gate that opens or closes for each element, right? So essentially, that's what filter really is. It's like a garage door. It may open when a car comes in, close when another car comes in. So authorized person can go in. Whoever shouldn't go in is blocked. So a filter is kind of like this garage door that opens and closes per car that comes through. Well, they also had yet another function available in Java 8, and this was called the limit function. If I say limit 3, notice I get only the first 3 values, the 11, 12, and 13, and I'm not getting any value after the 3rd element. But if you look at the limit function, what did the limit do? Limit takes an integer as a parameter, and it is like a door that is open but closes forever at some point, right? So in other words, a limit is like a door, like the door that we walked through. It was open when we came in, but now it's closed and nobody can come in anymore. That's what a limit is doing. But the limit works off of a count. So if I have some gifts, if I say, I'm going to give the gift for the first 3 people in the room, that would be the first 3 people in the room, and that's it, I'm going to stop. It is purely based on the count. count. On the same token, there is another method available in Java 8 as well, and this method is called the skip method. And I can say skip 7, and notice that it skipped 7 values, and then it gave us 81 and 91. So how does a skip really work? The skip takes int, and then, of course, I'm going to say after that, it takes an int, but then, of course, it is like a door that is closed but opens forever. So at some point. So this is the opposite of the limit. It is a skip will leave those many values and then start letting objects go through right after that. Well, if you look at this, unfortunately, notice the disparity here. The filter works off a logical entity. It says, for example, if I say those who are wearing a dark color shirt stand up, and those who are wearing a light color shirt sit down, that's like a predicate where for every person I'm examining the color of their shirt. On the other hand, the limit and take, unfortunately, only used a number, but there are times when we want to perform logical operation and stop processing at some point logically or resume processing at some point logically. We couldn't quite do that. So this was a huge deficiency. People started reporting issues with it. They were saying, how do I really solve this particular problem? The answer was, sorry, you got to write a lot of nasty code for it. That was a big deficiency in the part of the language, the API rather. Well, good news, that's been fixed right now. But before we talk about the fix, let's talk about something else which is kind of a little funny for me. And that is, I'm a big fan of Haskell. I consider Haskell as the gold standard for functional programming. And then, of course, we have Java as well, which is trying to do a lot of these things. If you look at Haskell, well, Haskell has a function called take. And what does a take function do? It takes the n number of values and gives you those values. But it is as if the language authors get together for dinner and ask each other, what is the name that you use? I will make sure I don't use that name. So they decided to use the name called limit over here. And so it was really funny, right? Hey, you guys call it take, we call it limit. Well, then, of course, Haskell has a function called drop. And guess what Java said? It would be not so cool to call it drop, we'll call it skip, because we are really cool that way. Well, that worked really well. But then Haskell has a take while, which takes a predicate as well. And then, of course, Haskell also has a drop while, which is also taking a predicate. Now we're in trouble, because what do we want to call it over here? If they called it limit while, they will be consistent with the Java naming convention. But you have to be consistently inconsistent. So they decided to change this to take while, go figure. So this drives me crazy, I have to tell you, because it's limit and take while. My hands want to type limit while, but it's called take while. Similarly, this one is going to be called as not skip while, but it's called as drop while. And both of these, of course, take predicates, and you can pass a predicate to this, and you can pass a predicate to this as well. And so those are two additions to the API right now, and you can use them very effectively. So what does a take while do? For example, I could say, I want to start giving a gift to everyone in the room until I find a person with a green color shirt. Well, then, of course, I'll start processing through until I find the first person who has a green color shirt, and I will stop giving the gifts at that point. So that's exactly what a take while function is going to do. So I'm going to go back over here and say take while, and in this case, I'll say given an element e is less than 50. Before we run this, let's go back and look at the filter one more time. Notice the filter gave us the 16 and 17 in the end, because 16 and 17 are after 51. Well, that's because it's like a gate that opens and closes. Take while, on the other hand, is more like a door, and the minute it hits 51, the door comes down, and it won't let any element to go through. Here's a way for you to think about it. In the case of imperative style of programming, what do we normally use? In the imperative style of programming, we use the break to break out of loop. Well, in functional programming, there is a break, and that's called take while. So take while is like your break. That's what it really is. You're able to break out of your iteration on a logical term rather than based on the count. And so that's why this is a very powerful operation to have a take while function. So take while will exit out of the iteration the minute that condition is no longer met. So I said E is less than 50. As long as E is less than 50, it marches through. The minute it runs into a value which is not less than 50, it exits the iteration and so no longer processes the value. Similarly, I can go back to this one and say drop while, and in this case, of course, given an element less than 50, and of course, in this case, it drops all the values until the condition is met, and the minute it is not met, and the minute the predicate returns a desired value, the door opens up, and all the values start going through at that point, and that's why you saw 11 through 14 not come through, but starting 51, we are seeing the values. So these are really two good additions to the Stream API. I'm really happy for having those two methods. The take while and drop while are absolutely very critical. So having said that, let's go a little forward. Let's talk about the int stream methods. Before we do this, let's go back to Java 8 for just a minute. In Java 8, we already had a iterate method on the stream. And you could use the iterate method on the stream for arbitrarily creating an infinite series of objects. And that worked really well. But I'm going to talk about something else we had in Java 8. So if I were to write a traditional for loop, if I say I is equal to 0, I less than 5, I plus plus, and I'm going to simply say output I, this is a traditional imperative style of looping. But what I really want to do, though, is because I'm such a fan of functional style of programming, I often tell programmers not to use that, but instead, where they can, to use the following facility in Java 8, and that is intStream.range. Starting from 0 up to 5, you can do a for each, and of course, you can say system.out.println, or whatever that you want to do with the processing of the value, you can do that very nicely over here. So you can see in this case, it ranges from 0 through 4, not including the value 5. This was already available in Java 8. Well, of course, in this case, notice in the top, I'm not touching the value 5. In the bottom one, I'm not touching the value 5 either. But what if I do want to include the value 5? Well, in the imperative style, we all know you would use a less than or equal to 5. What can I do about that in the int stream? Well, int stream already in Java 8 has a method called range closed, and the range closed method will cover the grounds for you, as you can see. So range if you don't want to touch the value, range closed if you want to include it. So one is an inclusive range, the other is not. So you can do this already. But chances are you may be working in a team where there is this one programmer who really hates change and keeps telling you none of this makes sense and don't want to do it. But you've been trying really hard to convince this programmer and say, this is the next best things from sliced bread, you should really use this, and the programmer just had enough of it. So what does this programmer do? Comes to work one day and says, if you think this is really awesome, do this for me, and says if I is equal to I plus 3. Now, at this point, your right response in Java 8 is, I am sorry, you win. That's the best response you can give. Because if you try to do this one in functional style, it's going to be really embarrassing. It is not easy to do. There's no real nice way to really capture this idea. And even if you struggle to do it when you finish it, your colleague will change this to something completely ridiculous, like a fast Fourier transformation in there. And you just have to say, I give up at this point. So the best thing is to say, you know what, you're awesome, that's great, just do it the way you like it, this is not for you. Well, thankfully, there's one more thing you can do to convince your team this time in Java 9 and later. So what can you do in Java 9? Well, if you want to do the top one, as you can see right in here, what did that do? It gave us the value 0, 3, all the way up to 15. Well, here's the good news. They have introduced a new method in Java 9 now, and that is called int intstream.iterate. Now, before we talk about the iterate method, I'll tell you why I'm really happy for the iterate method. I love code that is intuitive. I love code where I can get it without having to read a documentation. Let's think about this for a minute. Knowing Java 8, you know there are 4 famous interfaces in Java 8. One is the supplier, if you will remember. The second one is a consumer. The third one, you know, is a predicate. And the last one is a function. You know, a predicate takes an input, returns a Boolean. A function takes an input, returns something else to you. Now look at the for loop in the light of these interfaces. This looks like a seed value, isn't it? So you're providing a seed value for your for loop. What does this look like? Yeah, that's right. It's a predicate. That's what it is. It looks like a predicate, except we'll put a comma rather than a semicolon. And then over here, what does that look like? That's correct. It's a function. So notice how logical that now is. And that's exactly what you're going to deal with. So I'm going to say intstream.iterate. The seed is a 0. The predicate is given I is less than or equal to 15. Notice that one right there became this right here as a predicate, comma, and this one is a function, you said. So given I return I plus 3, and then I'm going to say dot for each, and system.out over here, and this is going to be outputting, so system.out println, and this is the new addition given to us in Java 9, and notice how it all is the same iteration range in both of those cases, and that looks really nice, as you can see. So that is basically what the iterate method is doing. It takes a seed value, it takes a predicate, and it also takes a function to do this. So that worked really nicely, but we also know that in Java, a traditional imperative style of programming, you can leave out the condition right in here. So you can leave it out, and you can say if I is greater than 19, then you want to break out of it. Well, in this case, of course, the top one gives us value including 18. How do I do that in the bottom one? Well, here's the thing you wouldn't do. Just because you put 2 semicolons, don't try to put 2 commas over here. That doesn't work. But the good news is the iterate method is overloaded. There are 2 versions of the iterate, 3 arguments versus 2 arguments. The one that takes 3 parameters, you send the seed, the predicate, and the function. The one that only takes 2 parameters, you send a seed and a function. So in this case, you send the seed and you send the function. But notice what we did in this code. We did not give the condition, so we are not giving the condition here as well, but we used the break. But you know what break is in functional style of programming, so we can definitely use that. So I can say take while, given an element is less than or equal to 19. So as a result now, you can see that that produces the same result as well. So you can use the take while and leave out the condition for providing it for that as well, and that is the new iterate method. So iterate is overloaded. It's got one that takes a predicate, one that doesn't take the predicate, and you can use whichever version you are interested in using, and so that definitely is a really good addition to the JDK as well. So we looked at the one with bounds, and we looked at the one without the bounds as well. Let's talk a little bit about optional. So what does optional do for us? Well, remember what the purpose of optional was. If I have a list of numbers, if I said numbers.stream dot filter, given an element is less than, let's say, 6. Then I say dot find first. Now, when you do a find first, what is it going to return? In this example, we would want the result to be first one, isn't it? So let's say greater than, let's go ahead and change it to greater than, let's say 5. Well, in this example, you would expect the result to be the value 6. But it may not exist if the value, what if I said 50 instead of 5? You don't want to return a null because null is a smell. You don't want to use null in your code. what did effective Java say about, getting a collection? Don't return a null, return an empty collection. That was a really good suggestion. But what if it's not a collection? What if it's a single value? Well, returning null is not fun. Well, that's where optional comes in. Optional is a wrapper that either wraps an empty or wraps a particular object. We have this from Java 8. So in this case, it gives us an optional. So let's go ahead and play with this and see how we can actually use this one. Before I write this example, I want to quickly note one thing. So I'm going to say void process, and I'm going to say optional of integer. And at this point, I'm going to take a quick break, so don't take any photo yet if you're going to take a photo. And I'm going to simply say, don't do this. There we go. Now you can take a photo. Well, I want to emphasize this because people will look at this and say, this guy's an idiot. And so I just want to emphasize, this is just a demo. Don't do this in real life. You don't want to take a parameter as an optional, so just don't take this example too literally. So I'm going to show you how this optional is going to work. So I'm going to print out the result right in here so we can see it. So notice it said optional 6 over here. On the other hand, what I'm going to do here is pass a 50, and as you would expect, it says optional of empty, as you can see. So that seems to work really well. So that's an example of how you can pass, use the optional to get the data. But the question is, how do you get the data out of the optional? That is the question. Well, I'll tell you how not to do it. If you may be tempted to do this, what does an optional do? An optional gives you the safety net, at least it tries to give you the safety net, not to get into an accidental null pointer exception. So if you're going to go to an object and get data out of it, optional says, dude, it may not exist over here. Can you please check? Well, unfortunately, though, they provided a method called get. Now, the get is the worst method in the JDK, because what does the get method do? It blows up if the value doesn't exist. It actually does exactly what optional was not intended to do, right? And so as a result, when you run the code, notice that if the value doesn't exist, what is going to happen at that point? Well, if the value doesn't exist, it's going to blow up. It's saying, sorry, I don't have the value, and it can fail at that point. So what do you do to prevent that kind of problem in your code? Well, what you can do is, in this case, you can ask it to, I'm surprised it's actually giving a empty right there. But anyway, what did I do actually? I'm not calling the process. You know what? That's actually a good idea. So yeah. So thank you. So wow, that's awesome. You guys this is why I love pair programming. Thank you. So there we go. So now when I go this, there you go. It is actually blowing up right there. So you can see this is kind of defeats the whole purpose, isn't it? So what do you do about it? Well, before we talk about what to do, I got a suggestion for you. The best thing you can do about get is forget, right? Don't ever use that method. This is a terrible method. Don't ever use it. Well, then how do I get the value out of it? Absolutely. Well, one way to do that is to say output right in here, and you can say result.or_else, and you can give a different value to it. In fact, in Java 11, Java 10, they added one more method called or_throw, or else throw. Now, what does or else throw really do? Guess what? It blows up. So how is it different from get? It just makes you feel better, right? That's the whole point. It actually tells you clearly, if you call me, I'll blow up. Get was quietly blowing up. This at least declares its intention. So that's what or else throw does. Same thing, except that they gave a new method name just to make us feel happy. So you can use those methods. Or what you can do in Java 8 is you can say if result.is present. Well, but that is an imperative style code. What if I want to do functional style code? You could do result.if present, and given an element, I want to output the element. So when you run this code, notice how beautifully it gave us the result of 6. So this was available in Java 8, and it is the if present. Now, as an observant reader here, you look at this and say, oh, wait a minute though. The if part is great, but what about if it is not there? Well, genuinely, they forgot the else part. And as a result, they realized, oops, so they now added an if present or else. But I like to speak positively about everything. Java is agile right now. In the first sprint, you get the if part. In the second sprint, you get the else part. So the point really is now you can have these two parts available to you. So you can say comma, and now you can say this is runnable, and I can simply output saying no value. And so that's an addition in Java 9, the if present or else, and you can use that pretty nicely now. So Java 8, you have if present. Java 9 and forward, you have if present or else. You can use that pretty nicely. So that's an addition to the optional. One other thing that they have added is the OR method. The OR method is going to return to you an optional. So here's a way to think about it. If you think about what OR else does, OR else is going to give you a result of, if I'll just put this syntax here, it's going to give you a result of type T. On the other hand, OR will give you an optional as a result. So if you call this, you get an optional of T as a result. So in other words, OR else allows you to inject a value, or else allows you to inject an optional of something else. So you can say optional of some value. So if you want to return a value, use OR else. If you want to continue with optional, but substitute an empty with another value, which is an optional, you can use an OR. That's available also. One last thing I'll mention about optional here is, let's go back to this code for a second, and let's change it to a stream, if you will. Now I can go to the stream and say result.forEach system.out over here, and I'm going to say println, and I'm going to just print it. Well, in this example, I'm using a stream, as you can see. Now if I go back to this code, I can call the process, and I can send the result of the filter, as you can see. So notice when I do this, it is going to print the value, which is all the values that are greater than 5. So that worked really well. So I got it, thank you. So basically in this case, all we did was that we provided this value over here, which is going to just display the result, which is treating it as a stream. But on the other hand, what if I were to say .find first over here? And if I use the find first, this is going to be an optional. Well, you clearly cannot pass an optional where a stream is expected. But the question is, why not? A stream, of course, can have 0, 1, or more values. An optional can have 0 or 1 value. Well, if that is really the case, we can convert it to a stream, and this gives an opportunity for us to convert an optional to a stream by using a .stream method on the optional. And that's been added nicely in Java 9 as well, so you can treat it as a stream very effectively. A couple of things I'll just quickly mention here is two beautiful methods added to collectors, which is the filtering and the flat mapping methods. We could easily spend 20 minutes on that one topic. Some of the favorite things I have here, but unfortunately we won't. Well, we'll also talk quickly about a few additions they have given in Java. And I think these are really good additions, given that we want to really favor immutability. So what if you want to create a list? So you can say string of names, let's say, and I'm going to say arrays.asList. We all have done this before, isn't it? Well, the problem with this approach is this array list is not immutable. It might give you an impression that it is. So when you run this code, you can say output names.add, let's say, Bill. Well, you will notice that that fails at runtime. But make no mistake, if you sneak around and say a set, and you are going to say 0, Bill, notice it did not give you an error. It actually modified. So it's not really immutable. Well, to fix some of this, what they have done is they have given you some really beautiful methods to do this. You can say list.off right now. And when you output this, you can see, in this case, it's got 2 names in here, and you can create it this way. So if I were to go back and put Bill over here, you will notice that this one contains 3 values. But out of curiosity, what is this? Names.getClass tells you that this actually is a list n. But notice it's immutable collection of list n. Well, if I don't put 3 values, but if I put 2 values, look at the beautiful thing. Well, actually, it's a list of 2. Don't look at this as Java 11, giving a little bit of a confusing message, but it's a list of 2 in here. Similarly, if you were to go to one element, that would be a list 1 that it would bring up. And finally, of course, if you don't put anything at all, it'll become a list 0. So these are pretty optimized collections under the hood. So that's basically what the list of is. It's immutable. You cannot add values to it. Similarly, you have a set of. And the last thing I will show you here is a map of. So map of string comma integer. And I can say values, let's call it as map is equal to map of. And look at the beauty of this. A comma, let's say 1, and B comma 2, and C comma 3. And then I can, of course, output the map right here. Very convenient. Of course, the question is, what if I give an extra key and I don't give a value? I do have to warn you, don't try this at home, because if you do, you'll make the compiler very angry. If you don't trust me how angry it is, be ready for it. It calls you really bad names, as you can see. So don't do that. So that's the beauty of this. It's all overloaded methods, and you can use that pretty nicely for creating immutable maps as well, or rather a very nice facility. A quick few mentions. Completable Futures has a few extra methods. I spoke about this during my Completable Future talk. You have Stack Walker, which gives a nice way to walk the stack. And finally, you have a JShell, which is one of my favorite tools in Java. It's a REPL for Java. You can use that as well. If you're interested in downloading the code examples I showed you here, please download them from my website over there. Thanks for coming. I hope it was useful.